It began with silence, a silence so deep, so vast, that even the sun's voice couldn't reach it. On November 14th, 2023, Voyager 1, humanity's most distant messenger, stopped speaking. What once was a steady pulse of data, whispering through the dark, suddenly unraveled into a stream of garbled code. A heartbeat lost in the void. For months the signal remained broken, incomprehensible. All we had was binary noise, a digital gasp from 15 billion miles away. And for the first time in decades, it seemed we had truly lost it. After everything, after the unimaginable journey it had made, Voyager 1 was drifting, alone and unheard. But NASA didn't give up. Not this time. This wasn't just a machine. They knew what it meant. The probe had become something more, a symbol of all our curiosity, our longing, our bravery. It had stared into the heart of planets, seen storms on Jupiter, traced the frozen breath of Neptune, and finally pierced the skin of our solar system. Losing it meant losing a part of ourselves. So with the quiet determination that has always defined human exploration, a team of engineers began working around the clock. They couldn't fix it directly. Voyager was too far away, too old, its systems damaged by decades of radiation. But maybe, just maybe, they could find a way around the failure. On April 18th, 2024, they made a choice that carried enormous risk. They rewrote the code, shifting vital systems to an untested part of Voyager's memory. And then they waited, a full day just for the signal to reach the spacecraft, another day for any response to come back. Then on April 20th, the impossible happened. Voyager 1 spoke again. After 5 months of silence, a broken old machine on the edge of nothing remembered its voice. It was still there, still alive, still listening. But what did it hear in the dark? To understand Voyager's silence, you have to understand where it came from. In the late 1970s, the planets aligned, literally. A once-in-175-year alignment of the gas giants gave NASA a fleeting chance. With just one launch, a spacecraft could visit all 4 outer planets by using their gravity as a slingshot. And so Voyager 1 and 2 were born. Fraternal twins, launched weeks apart, on a journey that would define the very edge of our solar system. Voyager 1 quickly took the lead, racing faster than its sibling. Within days, it turned around to look back at us, capturing Earth and the Moon together in a single frame, a grainy photograph from 7 million miles away. It was the beginning of something extraordinary. In 1979, both Voyagers arrived at Jupiter and sent back images that changed everything. We had never seen the planet like this, up close, textured, alive. They found hidden rings, discovered moons we didn't know existed, and for the first time, saw Europa's cracked, icy skin, an ocean world that might still hold secrets beneath its frozen surface. It was only the beginning. By 1980 and 1981, Saturn loomed in their view. Its rings weren't just beautiful, they were intricate, sculpted, layered like frozen ripples in time. Voyager 1 flew close to Titan, Saturn's mysterious moon cloaked in haze. What it saw changed the mission forever. Titan was hiding something beneath that thick, amber atmosphere, something Earth-like in temperature and chemistry. And so, Voyager 1's journey into the outer planets ended. In chasing Titan, it had sacrificed the path toward Uranus and Neptune. That baton would pass to Voyager 2. From that moment on, the 2 probes were separated not just by space, but by fate. Voyager 2 carried on, diving into the icy reaches of Uranus and Neptune, worlds colder, stranger, and lonelier than we had imagined. But Voyager 1 turned toward the stars. Its cameras were eventually shut off. Power had to be saved, but not before one last image, a pale blue dot taken from 3.7 billion miles away. In the frame, Earth was nothing more than a speck suspended in a shaft of sunlight, barely visible, barely real, and yet it was everything. Carl Sagan, the great voice of wonder, called it a mote of dust suspended in a sunbeam. It was Voyager's last photograph. After that, it would see nothing, only feel, only listen. And it did. For over 3 decades, it kept drifting, through a space so empty it might as well not exist. Until one day the silence changed. On August 25th, 2012, Voyager 1 crossed the heliopause, the invisible border where our sun's influence ends and true interstellar space begins. The numbers told the story: a sudden drop in solar particles, a strange rise in cosmic radiation. Voyager had pierced the bubble that surrounds our solar system, breaking into a new kind of dark. It was the first time anything built by human hands had entered this realm. There was no fanfare, no sound, only a shift in the data and the growing awareness that we had finally stepped outside our cradle. But space wasn't as simple as we once thought. Voyager revealed something unexpected. The boundary wasn't a gentle fade. It was abrupt, jagged, alive. Solar particles didn't just thin out. They crashed into interstellar winds, creating waves, turbulence, invisible storms. The edge of our solar system was more like a storm front than a border. And beyond it, the silence wasn't empty. It hummed. A low, persistent frequency, 3 kilohertz, soft and steady like the breath of something sleeping. The sound, converted from plasma waves, lasted for years. It was ancient and constant, unchanging even as Voyager traveled farther. What was causing it? We still don't know. Maybe it's the voice of deep space itself, the quiet rumble of stars and gravity and time. And so the probe drifted farther into that hum, far beyond the planets, past the sun's final whispers, and into a sea of questions we may never answer. Voyager wasn't supposed to last this long. It wasn't built for this, and yet it endures. At the edge of everything, a machine the size of a car, running on 1970s memory and nuclear dust, still speaks. And Voyager wasn't just floating through empty space. It was passing through a kind of invisible structure, a colossal bubble blown by the sun itself. It's called the heliosphere. Not that you could ever see it. There are no glowing walls or shimmering boundaries. But it's there, like the thinnest skin stretched around everything we've ever known. Inside it, solar wind flows freely, streams of particles flung out by the sun at hundreds of kilometers per second. But beyond it, the solar wind dies, slows, crashes against the winds of the galaxy. The edge is called the heliopause. Voyager crossed it twice. Voyager 1 first in 2012, then Voyager 2, 6 years later in 2018. Each crossing felt like stepping off a cliff, abrupt, final, strange. The moment they passed that threshold, everything changed. Radiation levels spiked, temperatures dropped, the sun's influence fell away. They were outside, and then came the data. Voyager 2 measured the density of particles beyond the heliosphere. What it found didn't make sense. At one point, just beyond the edge, the number of particles began rising instead of falling. Not just a little, a lot. At 24.2 astronomical units past the heliopause, the density had reached nearly 0.12 particles per cubic centimeter. That might not sound like much, but in the void of space, it was a strange and sudden spike. Why? No one knows for sure. Some say it's where the solar wind collides with the interstellar medium, a cosmic traffic jam, particles slamming into each other, piling up like cars in a storm. Others think we've only just begun to understand what space really means out here. But the truth is, Voyager stumbled into something we never expected, a hidden layer of the cosmos. And it turns out that bubble wasn't the only one. Because surrounding the entire heliosphere is something much bigger, much older. The local bubble. You could travel at the speed of light for 1,000 years and never see the end of it. It's not a place, it's a scar, a wound left by violence. Scientists believe that millions of years ago, a chain of supernovae, massive dying stars, exploded across this region of the galaxy. Each explosion sent shockwaves through space, blasting the interstellar gas outward and clearing out everything in its path. What was left behind was a vast hollow, an empty cavern of space. That's where we live. And somehow our sun ended up right near the center of it. The odds of that are staggering. Our sun wasn't born here. It wandered in 5 million years ago, like a ship drifting into a calm harbor. Right when Earth was beginning to teem with life. Right when mammals were rising. right before the first spark of human consciousness, and it settled here, in this quiet, empty shell blown out by the deaths of ancient stars. It's hard not to wonder, was it chance or something more? Because the local bubble isn't just empty, it's protective. Without dense clouds of interstellar dust and radiation, the sun's heliosphere could stretch far and wide, forming a shield that wraps around us. It keeps out the worst of the galaxy's fury. It lets Earth remain stable, safe, alive. Voyager didn't just show us what's out there. It showed us how rare our safety truly is, and it's not permanent. As our solar system orbits the center of the Milky Way, one full loop every 200 million years, we pass through denser and more dangerous regions, spiral arms filled with stars, gas, dust, and death, supernovae, gamma rays, collapsing clouds. It's not always gentle. Some scientists believe that every time we pass through one of these galactic arms, Earth has suffered mass extinctions, one after another. 415 million years ago, then 322, 345, and again, just 33 million years ago. It's as if the galaxy breathes in cycles, periods of silence, broken by waves of destruction. But right now, we're between the arms, in the lull, in the bubble. A moment of calm that may last just long enough for us to figure out how to survive what's coming next. And maybe that's what Voyager is really telling us. Not just what's out there, but what we're inside of. A gift, a shelter, a rare and precious pause in an otherwise violent universe. That's what makes Voyager's story more than just scientific. It's personal, because all of us, every human being who has ever lived, has been inside this invisible bubble, protected, cradled. And now, for the first time, a piece of us has slipped out, into the dark, into the unknown, and it's still go. There's something deeply human about the idea of goodbye. It's the sound of a last signal, the final breath of a machine drifting further away than any living thing has ever gone. And yet it still speaks. Voyager 1 is now over 23 billion kilometers from Earth. Voyager 2 is not far behind. Both are flying silently into a place where even light takes years to arrive. No spacecraft has ever traveled so far, not even close, and soon the silence will be complete. Their power is fading, one instrument at a time, shutting down. Their long goodbye is already in motion. But maybe that's not the end of the story, because Voyager was never just a probe, it was a message. Tucked into the side of both spacecraft is a small disk, gold-plated, etched with the hopes of a world, the golden record. It carries greetings in 55 languages, sounds of Earth, wind, thunder, laughter, the cry of a newborn baby, a kiss, a heartbeat, and music. Beethoven, Bach, Blind Willie Johnson, and a lullaby from across the ocean. It holds photographs, too, of cities and fields, of families, of someone holding their child for the first time. It even includes instructions, how to play it, how to find us. Just in case someone, somewhere, someday, does. Carl Sagan once said, "The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Hope. That's what Voyager really carries. Not data, not coordinates, but hope. Because long after the signals stop and the systems go dark, Voyager will keep going. It doesn't need power to drift. No star will pull it in. No planet will catch it. It will wander the galaxy for billions of years. Longer than Earth may even exist. Longer than humanity might survive. Think about that. One day, everything we know, our cities, our countries, even our sky, will change. The continents will shift. The sun will grow hotter. The oceans might rise or vanish. Mountains will crumble. Our species might evolve or fade or be replaced. But Voyager will still be out there, whispering across eternity. And if something, some being with eyes or senses we can't even imagine, ever finds it, they'll know this. We existed. We tried to understand. We reached out, not with weapons, not with conquest, but with music and kindness and the sound of a mother's voice. And maybe that's enough. Voyager's discoveries didn't just reshape science. They reshaped our story. They showed us Neptune's deep blue heart, Saturn's swirling storms, Jupiter's erupting moons. They showed us that the universe is wilder than we thought, stranger than we dreamed. But they also turned around and showed us, that pale blue dot, hanging alone in the vastness. That's Earth. That's home. Every war, every poem, every love story, every sacrifice, every child ever born. All of it on that dot. And we sent a piece of ourselves away from it, hoping to be remembered. Not as conquerors, but as explorers, as listeners, as children of the stars looking for family in the dark. So yes, one day the Voyagers will fall silent. Their antennas will turn cold. Their instruments will sleep forever. But even then, they will continue on, not as machines, as monuments, to curiosity, to courage, to the belief that even the smallest voice flung into the void can one day be heard. The Voyagers left Earth with less computing power than your phone, wrapped in 1970s engineering and hope as their fuel. And look how far they've gone. Look what they've shown us. Look what we became because of them. The edge of the solar system wasn't a wall. It was a door, and we walked through it. And somewhere, out there, they're still flying, into the stars, forever.